Hi, this is Dave Aikens with Savvy Optics, and this is a not so brief presentation on going through some examples of surface imperfections that hopefully will be useful to you. And real surface imperfections are kind of interesting to look at. Um, so Savvy Optics has been around for quite a while now, 15 years, and we've been working in the area of surface quality that whole time. We make some products that do surface imperfection inspections. We also teach a lot of classes on how to do surface quality tolerance evaluations. And we usually refer to surface imperfections or flaws as scratches and digs. And a scratch or a dig that's a cause for rejection would be called a defect. And the reason we got involved in this is because scratches and digs and other surface imperfections are the most cited cause of rejection for optical components in precision optics. So this is a pretty big deal. This is a real common problem that our industry has that we have to evaluate for surface quality, and a lot of parts get rejected. Scratches and digs can be evaluated by two methods. Either evaluate them by their size, so the width of the scratch and the diameter of the dig, or they can be evaluated by their appearance or their visibility or their brightness or how big they look. So we refer to the visibility method, which is described in ISO and MilPerf 13830, and the ANSI OP1002. We'll refer to that as the visibility method, and then we'll refer to the ISO specification of imperfection sizes. Based on DIN 3140, we call that the dimensional method. I'm not going to go into that in a lot of detail. This is more about judging based on the visibility method, but I wanted to make sure it was clear that there are actually two ways to do this. Savvy Inspector does both. We originally developed the system, though, for this method, the MIL and ANSI visibility method. And in this system, the surface imperfections are evaluated by their brightness or their appearance on parts. It uses a pair of numbers, first numbers for scratches, second numbers for digs. And these numbers are completely arbitrary. They refer to a set of master scratches and digs, and they have very specific grades. The isodimensional method is a totally different system. It uses size to determine the grade of each of the imperfections. It's based on an area measurement of the imperfections, and maximum allowable imperfections can be traded in for smaller imperfections. So there's an accumulation system that's built into it, just like there's an accumulation system in visibility. Long imperfections are defined as anything longer than 2 millimeters in the ISO dimensional method, and digs are anything shorter than 2 millimeters. So there's a fine dividing line in the ISO standard. In the MIL and ANSI standard, it's not that clear. So it sounds easy, right? Okay, I look at a dig and judge its grade and say, okay, that's a number 50. I look at a scratch, judge its grade. I say, okay, that's a number 80. I measure its length. But it's not really that simple. When you actually look at real scratches and real digs, there's a lot of judgment that has to go into it. Here's an example. This is just a simple dig on a silicon carbide blank. And when we look at it with the Savvy Inspector, we determine that its grade is a 21. Savvy Inspector reports whatever the grade is in as a number for apparent size in units of tens of microns. So this dig is about 210 microns wide. So the rules in the ANSI method would say you have to round this up to a 40, but actually the human eye would probably grade that as a 20. It's so close to the number 20 that it would probably round it down instead. So that's an important decision rule that the inspector needs to make. When do you round up to the next grade? This is a comet scratch or a comet tail scratch. And these are actually, they're straightforward to grade, but they can be frustrating because all scratches are judged by their brightest point. And in a comet tail, that brightest point is near the place where the pullout occurred. So in this particular scratch's case, the brightest section is an 80, but then it faintly fades away for several millimeters more. So you would judge that as a number 80 scratch that's 4 millimeters long. You judge the length based on when the scratch disappears, and you judge the grade based on the brightest point. This is another comet tail. This is a much shorter one. So on a shorter comet tail, You again grade it based on the brightest point along the scratch, but then you have to evaluate its length as well. In this case, it's about 1.2 millimeters. This is a curved scratch on a window. Curved scratches are just as easy to grade in terms of the brightness. So this one's brightness is 100, so that would be a cause for ejection, and the length is about 2 millimeters long. And you'll notice that the length display in the screenshot actually says it's 81 millimeters long. That's because I forgot to zero the encoders before I took the screenshot. So you can see by eye it's about 2 millimeters long. People ask, what do you do with a curved scratch? Do you have to like measure the length, or do you use like a French curve or something? And the answer is no. You just estimate its length, because if it's going to fail because you've judged the length wrong by 100 microns, then it should fail anyway, right? This is a much more common type of scratch. It's a long, faint scratch, and these are pretty common, especially on harder glasses. This particular scratch is about a number 10, and the scratch covers about half of the part, so it's about a 13 millimeter long scratch. And because the scratch was so faint, it was really difficult to judge where the scratch ended. That was the most challenging part. This is an edge scratch, again on a silicon carbide blank. Here, the brightest spot is about a 40, and the length is 3 millimeters. But the challenge with this one is, when is it in the clear aperture and when is it not? Because if it's outside the clear aperture, you don't judge it as a scratch on the surface. You judge that separately. So in this particular case, I think the whole scratch length is out of the clear aperture, and so I would let this pass. Here's another edge scratch. This one's got a bit of a curve to it. You can see it's long and thin, and there's also some cleaning residue in this shot. The brightest point on this curved scratch is about number 20. And it's not 33 millimeters long. Once again, I didn't reset the encoders when I took the screenshot. It's about 8 millimeters long. But again, you have to use the judgment of when do you enter the clear aperture to decide what the length of that number 20 scratch is going to be. There's another fairly pronounced scratch. This is on a filter, and this is what I mean when I say real scratches and digs aren't that simple. Is this one scratch? Is it 5 scratches? What do you do with this? In this particular case, the brightest part was over an 80, so it would fail no matter what. It's cause for ejection, so you don't have to agonize over it too much. But as a rule, you've got to make a decision as to whether or not you judge that as a single imperfection, because it clearly was caused by a single action, or is this a series of imperfections that need to be judged separately? This one's interesting. Looking at a thin window, found this crack. This is a fracture right through the glass, and fractures are never allowed. This is an unusual fracture. Most fractures show up on the edges. This fracture was right in the middle of the part. Any size fracture or crack is cause for ejection. It's never allowed. Here's a couple of small imperfections on a thin window, and we're going to look at each of them separately, and they pose a separate kind of problem. You can see that they're quite short, but they're fairly bright, right? So do you judge that as a number 80 scratch that's less than a millimeter long, or should you just judge it as a small dig that's, maybe a 10 or so in dig size? And that's an important judgment call, right? It fits in the 1 millimeter box. In the ISO system, it would obviously be a dig, but in the ANSI and MIL system, it's not that clear, and you have to have decision rules to decide. This one's a little easier. It's a 120 scratch, and it's a 46 dig, which would be rounded up to a 50. So once again, you got to make a decision. It's about a millimeter long. Am I going to call that a scratch or a dig? Visually, it would be easy to determine that it was long. It had a long aspect ratio, but at the same time, it's pretty short. My rule that I use, which is not written anywhere in these standards, is I look at it both ways. Every imperfection is evaluated as a potential scratch or a potential dig. And if it passes through either method, then that's what it is. And if it fails for both methods, then it doesn't really matter, right? So that sort of removes the challenge of what to do about these really short digs or short scratches. This is another common one, and again, it requires some serious judgment. This is called a skip scratch. It's a long string of very short scratches. Really, when you look at it visually, certainly under a loop, you would see a whole bunch of little dots, and you have to decide, okay, is this a scratch that I'm going to judge based on the total length of the skip scratch and evaluate its grade based on the brightest point? Or is this a string of digs that needs to be evaluated where each dig has to be calculated separately? So this is another important judgment call that inspectors have to be able to make. Here's something that we see a lot of, and that's, cleaning residue. So what do you do with cleaning residue? Is that cause for ejection? Well, it turns out it is. If you have cleaning residue on a part, that part does not pass, right? So you could probably clean off that cleaning residue and get it to pass, but as it is, it's not a shippable part. And the reason we make that rule is because sometimes you can't clean the residue off. Like if the cleaning residue is under a coating or something, then you wouldn't be able to get rid of it, and it's an area imperfection. So this is a kind of imperfection that's not a scratch, it's not a dig, but it's still cause for ejection. And we would refer to these as area imperfections, and they're not that uncommon. This is an image of some commercial craft glass that we were trying out just to see, how does this look compared to real glass? And it looks horrible, right? It's just this complete starry sky. This is actually a clean part, and the background is just, really, really bright. So what we've been doing with the Savvy Inspector is we recently added the feature where we report the total integrated scatter over 1 square millimeter. And that's on this slide right here. In this location here, you can see the scatter at that point is 155 counts out of 254. So that's really bright. And so you can tell something about the texture or the polish quality of a part just by looking at its scatter. You can compare that to some of the earlier slides if you go back and look, and you'll see that on silicon carbide, scatter is in the 1 to 10 range, and in typical commercial glass it's more like 20 to 50, but it would never be 155. That's completely poor quality polish. There's another one of these area imperfections. This is on a coated window, and it's hard to say what this is. It could be in the coating, it could be on the substrate. It could be cleaning residue, right? Maybe it cleans off. Well, it turns out it didn't clean off. It is actually in that coating. It's damage to the coating. And so it's obviously cause for ejection. This is a very large area imperfection that would be a cause for ejection. But one of the reasons we use the Savvy Inspector is so that we can document possible rejections, and the documentation allows the manufacturing engineers to maybe figure out what caused this, do some forensics on this particular part. So in all these cases, these are all screenshots that could be stored and reviewed later for an MRB decision or for a root cause corrective action. So sometimes it is easy, but there are a lot of imperfections that are really kind of challenging. Real imperfections aren't little dots and lines on paper, right? They're much more irregular and non-uniform, right? So a lot of imperfections, simple digs and simple scratches, they can be graded objectively, but the other ones, you really gotta got to think about it. You got to make some judgment calls, and as we say, a picture's worth 1,000 words. So hopefully that was helpful. Great. I'll see you next time. Thanks for watching. Bye now.